Hello. Pull. Oh. Ooh. Yeah.
Good day, everyone. So for today's topic, we're going to talk about the use of mother tongue in teaching elementary science. So, science literacy is the focus of the new K-12 curriculum. Although science utilizes global language like English, starting learning with the mother tongue for conceptual understanding in the early grade has more advantages. Science becomes more relevant and meaningful because it will relate with the context of the learners. It will connect meaningfully to the social, health, and environmental concepts that are the foundations of early grades science learning. There will be 4 lessons in this module. Lesson 1 is looking into science in K-3 with mother tongue as a medium for teaching and learning. Lesson 2, using the common science terms and concepts in the mother tongue to teach and learn. Lesson 3, the science process skills for learning and teaching. And Lesson 4, getting to teach, preparing the lesson plan. So let's inculcate concepts. The K-12 science curriculum of the Department of Education provides all teachers a guide for all teachers. It underscores and recognizes how important science is in the everyday life of human beings. Science integrates technology in the social, economic, and ethical aspects of life. There are various concerns that the science may contribute their solution. Some examples are hunger and food, climate change, population, pollution, weather disturbances, and many more. As a framework, the Department of Education presents a conceptual diagram of what science education is all about. Here is the framework the Department of Education presents. The diagram reveals the ultimate aims of science is scientific, technological, and environmental literacy. This can be achieved if the learners can, first, demonstrate scientific inquiry skills. Second, understand and apply scientific knowledge. And third, demonstrate scientific attitudes and values through different ways of delivery, which are based on sound learning theories. Based on the framework, the number 1 focus of this is multi or interdisciplinary approach. Second, science technology society approach. Third, problem issue based learning. Fourth, inquiry based approach. And fifth is the brain based learning. Now, to continue and learn more about this framework, let us listen to our next reporter.
Thank you, Ms. Mary. That was indeed a beautiful introduction for our report. And now let's continue our discussion. I am Alma Grandilawan, and we're going to talk about the attributes of a scientifically literate person according to the DepEd. So number 1, a scientifically literate person is a critical problem solver. This means that the individual can analyze complex issues, identify underlying problems, and develop effective solutions by applying scientific reasoning, data analysis, and creative thinking. Number 2, a scientifically literate person is a responsible steward of nature. This means that the individual prioritizes the protection, preservation, and sustainable management of the environment. Number 3 is an individual should be innovative and creative citizens. This means that she or he can embrace scientific and technological advancements. Someone who thinks outside the box and contributes original ideas to the society. Number 4, informed decision makers. This means that a scientifically literate informed decision maker is an individual who bases their choices on a thorough understanding of relevant scientific information, facts, and data. And lastly, number 5, effective communicator. This means that a scientifically literate effective communicator is an individual who excels in conveying scientific information clearly, listening actively, and fostering open dialogue. They possess strong verbal and nonverbal communication skills, enabling them to articulate scientific concepts, provide feedback, and engage with others in a constructive manner. All of those mentioned attributes should be developed starting in the early grade levels of schooling and progressing to the higher level. All of those characteristics mentioned should be developed starting in the early grade level of schooling and progressing to the higher level. And now let's move forward to another topic. As we all know, there are 4 science topics in the K-12 curriculum, and these are the areas of life sciences or the biology, physics, chemistry, and the earth sciences. These topics or these areas follows a spiral progression. This means that the topics are discussed from basic concept to more complicated ones. And there are 3 reasons why spiral progression is used in teaching science. Number 1, it is to avoid disjunction between stages of schooling. The spiral progression approach makes sure that what students learn in one grade level connects smoothly to what they should learn in the next. This prevents big jumps or gaps between different stages of their education. Number 2, to allow learners to learn topics and skills appropriate to their developmental stage. This allows them to learn things that are appropriate for their age and how their brain is developing, rather than sticking to just one subject area. And lastly, number 3, to strengthen the retention and mastery of topics and skills as they are revisited and consolidated. The spiral progression approach reinforces what students have learned before. This helps them remember and truly understand the key topics and skills better over time. Let's say, for example, in grade 4, the learners are taught about the parts of the plants like the leaves, the roots, and stuff, etc. And as they move forward to grade 5, they are taught about how the plants makes their own food. And from that, we can conclude that the learners are taught about from the basic to the more complex one. Let's move forward to another topic, which will be about the set of standard competencies support the framework and the learning progression in science learning. Let us see how the competencies progress along kindergarten, grade 1, grade 2, and grade 3.
In kindergarten, the learners will demonstrate an emerging understanding of the parts of their body and their general function, such as in plants, animals, and varied materials in their environment. Understanding of their bodies and what is around them is acquired through exploration, questioning, and careful observation as they infer patterns, similarities, and differences that will allow them to make sound conclusions. As they move forward to grade 1, the learners will use their senses to locate and describe the external parts of their body, to identify the external parts of animals and plants, to tell shape, color, texture, taste, and size of things around them, to describe the weather and what to do in the different situations, to use appropriate terms or vocabulary to describe these features, to collect, sort, count, draw, take things apart or make something out of the things, to practice healthy habits, examples, washing hands properly, choosing nutritious food, and safety measures, examples, helping to clean or pack away toys, asking questions and giving simple answers, or description to proving questions. At the end of the grade 2, learners will use their senses to explore and describe the function of their senses, compare 2 or more subjects and using 2 or more properties, sort things in different ways and give a reason for doing so, describe the kind of weather or certain events in the home or school and express how these are affecting them, do simple measurements or length, tell why some things around them are important, decide if what they do is safe or dangerous, give suggestions on how to prevent accidents at home, practice electricity, water, and proper conservation, help take care of pets, plants, and tell short stories about what they try to do, what they have seen, or what they feel. And lastly, at the end of grade 3, the learners can describe the function of the different parts of the body and things that make up their surroundings, such as rocks and soil, plants and animals, the sun, moon, and stars. They can also classify these things as solid, liquid, or gas. They can describe how objects move and what makes them move. They can also identify sources and describe uses of light, heat, sound, and electricity. Learners can describe changes in the conditions of their surroundings. This would lead the learners to become more curious about their surroundings, appreciate nature, and practice healthy and safety measures. The science concepts are learned and process skills are acquired through the various activities carried out in the classroom. A well-planned lesson plan is a tool that will help the teacher facilitate and conduct them.
That ends my topic. Let's have Miss Kyle Marie Rada to continue the discussion.
Thank you, Elma. Good day, everyone. I am Kyle Marie Rada, and I will going to continue the discussion. There are millions of words that we speak in our mother tongue, right? We can communicate and talk using these words among our peers who speak the same language in order to understand each other. Language is a medium of communication. Language is how people communicate with each other. It is a tool we use to express our thoughts, feelings, and ideas. Without language, it would be hard for us to share information and connect with others. When we use our mother tongue in communicating, we understand better, right? Hence, in teaching science, we need to use our mother tongue. Today, we will going to learn the common words used in science for teaching and learning in elementary grades. So there are 5 clusters or major topics that are related to science. For cluster 1, parts of the body. For cluster 2, plants. For cluster 3, animals. For cluster 4, earth, sun, and moon. And for cluster 5, words that describe such as colors, numbers, sizes, and others. Today, we will going to learn the Hiligaynon, mother tongue, and English words or terms of each cluster that will be used in speaking, writing, and reading in science subject. So here are the common words used in science for teaching and learning. In cluster 1, words that relate to parts of the body. In Hiligaynon, we have liog, kamot, tiyan, batiis, and tudlo sa tiil. In our mother tongue, it is liog, kamot, tiyan, batiis, and tudlo sa tiil. In English, it is neck, hands, stomach, legs, and toenail. In cluster 2, words that relate to plants. In Hiligaynon, we have bulak, liso, hilamon, dahon, and bunga. In our mother tongue, it is buwak, liso, sagbot, dahon, and bunga. In English, it is flower, seed, grass, leaves, and fruit. In cluster 3, words that relate to animals. In Hiligaynon, we have kuring, ido, pispis, manog, and pabo. In our mother tongue, it is iring, iro, langgam, bitin, and pabo. In English, it is cat, dog, bird, snake, and turkey. In cluster 4, words that relate to earth, science, and moon. In Hiligaynon, we have bituon, aga, gabi, ulan, and duta. In our mother tongue, it is bituon, buntag, gabi, uwan, and yuta. In English, it is star, morning, night or evening, rain, and land. In cluster 5, words that describe. For number 1, in Hiligaynon, duwag. In our mother tongue, color. In English, color. We have here berde, lunhaw, green, dilaw or kanaryo, dalag, yellow, kahil or dalandan, kahel, orange, kaki, tabunon, and brown. For number 2, in Hiligaynon, we have mga inadlaw sa semana. In our mother tongue, it is mga adlaw sa semana. In English, it is days of the week. We have here Lunes, Lunes, Monday, Miyerkules, Miyerkules, Wednesday, Biyernes, Biyernes, Friday, Sabado, Sabado, Saturday, Domingo, Domingo, and Sunday. For number 3, in Hiligaynon, mga numero. In our mother tongue, mga numero. In English, counting words. We have here tatlo, tulo, 3, ano, uno, 6, pulo or napulo, napulo, and 10. For number 4, in Hiligaynon, kalabaon. In our mother tongue, katason. In English, length. We have here malaba.
Good afternoon, everyone. My topic for today is all about science processes skills for learning and teaching in lower grade. The American Association for the Advancement of Science, or AAPS, has originally introduced the processes of science. These are grouped into basic science processes, which include the first one is observing, comparing, classifying, and measuring. What is observing? Observing means using your senses to gather information about the world. And comparing means identifying similarities and differences between objects or phenomena. Classifying means grouping the things based on shared characteristics, and last but not the least, measuring. It means quantifying observation using tools and units. Next, we have the use of numbers. We have inferring and predicting. Let's go first with inferring. Inferring means drawing conclusions based on observation and evidences, while predicting means using what you know to forecast what might happen next. Time relationship and the integrated science process, which include hypothesizing, controlling of variables, interpreting data, making operational definition, experimenting, and formulating models. When we say use of space and time relationship, it means understanding how things change over time and how they are positioned in space can be crucial in scientific studies. And integrated science processes means that these processes build upon the basic skills and involve more complex thinking. Let's go first with hypothesizing. It means formulating a testable explanation for an observation. Next is controlling variables, isolating the factors you're studying to see its scientific effect. Interpreting data, making sense of the information collected through observation or experiments. Making operational definition, defining concept in a way that allows them to be measured or observed. Next is experimenting, designing and conducting a procedure to test a hypothesis. And last but not the least, formulating models can create a representation of systems or processes to explain observations. By understanding and applying these processes, scientists can systematically investigate the world around them to gather evidence and advance our scientific knowledge. And that's all for my topic.
I am Brian J.T. Pueselio. I am going to continue the discussion. The basic science process skills are formally introduced in K to grade 3. Let us revisit some of these processes. Science processes skills for K to grade 3. First, observing. Observing involves using various senses to objectively gather information about an event's object. For example, of observation based on your senses. How do you say this observation in your mother tongue? What you see, yellow, green, blue, or orange. What you taste, sweet, sour, salty, or bitter. What you feel, soft, smooth, rough, or hard. What you smell, bad, pleasant, or smells like. 5. What you hear, loud, soft, shrill, or sound like. 2. Inferring. Inferring making an educated guess about an observation based on previous observation. For example, the bus stopped by the school in every 7 o'clock in the morning. Then it can be inferred that on a Monday morning at 7 a.m., the bus will be there. Third, classifying involves grouping events into categories based on properties, characteristics, and criteria, requiring comparison to identify similarities and differences. For example, Group A, all fruits. Group B, all grains. 4. Measuring involves comparing two things or objects, either standard or non-standard, to determine their quality and precision. For example, a meter stick is a standard measure to compare with the edge of the table. 5. Communicating involves using words or graphic symbols to describe actions, objects, or events. For example, describing the temperature of water through a graph over a period of time. 6. Predicting is the process of describing the outcome of a future event based on normal patterns, such as sunrise, sunsets, or plant growth. Example, predicting the growth of corn seeds over a period of time. And that ends my topic. And let's have the next reporter to continue the topic.
Making science process skills activities. Here are the some guidelines on how you will do it. First, identify the grade level where the activity will be used. So you determine the specific grade level of the students who will be participating in the science activity. This helps ensure that the activity is appropriate for their age and level of understanding. Number two, review the science competency standards and constant standard and choosing your topic. So, familiarize yourself with the science competency standards and content standards that are relevant to the grade level. These standards outline the knowledge and skills that students should acquire. Choose a topic for the science activity that aligns with these standards. Number three, review what process skills to be developed from the list given above. So look at the list of process skills provided and identify which ones are relevant to the chosen topic and grade level. So process skills are the scientific skills and abilities that students develop through hands-on activities such as observing, predicting, and experimenting. Number four, develop science activity that will utilize local materials and raw objects to avoid materials that will require learners to buy many things. Design the science activity in a way that utilize local available materials and real objects. This makes the activity more practical and accessible for the students. Avoid using materials that would require students to purchase many things as these may create barriers to participation. Number five, develop science activity that will allow collaboration, competition, and individualism. Create a science activity that encourage collaboration among students, allowing them to work together in terms or groups. Additionally, consider incorporating elements of competition or individualism to make the activity engaging and motivating for the students. Number six, develop science activity that is enjoyable. To ensure that the science activity is enjoyable and interesting for the students, this can be achieved by making it hands-on, interactive, and relevant to their lives and interests. When students find the activity enjoyable, they are more likely to be motivated and engaged in their learning process. So the last number, follow the simple format suggested in the box below. So use the suggested format provided in the box as a guide for structuring the science activity. This format may include a section such as an introduction, materials needed, procedure, and assessment. Following a consistent format helps ensure the clarity and organization in the activity design. So that's all, and that's all the guidelines on how you will create a science activity.
Designing a lesson plan to guide in teaching science in the mother tongue. As a 21st century teacher, you're not just delivering lessons, but also designing the curriculum. When designing a lesson, it's important to base it on educational theories and principles, such as using the mother tongue in early education. The transition years of K to 12 may present challenges as you pioneer the use of the mother tongue. However, when students in your class enjoy and actively participate because they understand the lesson better, it will inspire you to teach even more. A lesson plan is a detailed description by a teacher for a specific unit of time with specific objectives within a subject matter. The basic components of a lesson plan include the intended learning outcomes or objectives, subject matter, procedure, are divided into preparatory activities and the lesson proper, and assessment of learning outcomes. An example of a lesson plan in elementary science focuses on the topic of pushing or pulling objects. The intended learning outcomes include understanding that force is applied to move objects, recognizing that the pull moves objects towards oneself, and realizing that a push moves objects away. The subject matter includes science concepts, science processes, and the materials to be used. The procedure involves a preparatory activity, lesson proper, with motivation and activities, conceptualization and application. The assessment of learning outcomes involves multiple choice questions to gauge understanding.